Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Hi, it's Jeff Carpenter, and I am live here in the studio for another episode of the Distributed Data Show. But I'm actually not the host of today's episode. The host of today's episode is David Gilardi, who is remote from sunny Orlando, Florida. Welcome, David.
Why, thank you, Jeff. Hello. So since I'm going to host today's show, I guess I should introduce our other two evangelists. We have Dwi Duan.
Hello.
And Luke Tillman, the illustrious Luke.
I like that. Oh wait, I should always be referred to as the illustrious.
Yeah.
Where's my title, man?
So, yeah, sorry, I didn't give one to Dwi. I just gave right to Luke.
Yeah.
But so we were having some internal discussions and another discussion with a DSC user about the topic of microservices, right? And some best practices, some discussion on the best practices of microservices and the intersection of the data tier and that kind of deal. So kind of, spawned this particular conversation. So I'm just going to get right into it and ask, what is a microservice?
So, so that's a fun question. Lots of people have different takes on what is a microservice. And instead of maybe defining what a microservice is, let's talk about what a microservices architecture looks like, maybe. And kind of a good way to maybe think about it is to contrast it to how we've built applications for many, many years. So sort of the traditional, many years ago model that we would use is sort of this monolithic architecture where we would build an application as one sort of big running process. Maybe we had libraries and modules and stuff in our code, depending on what programming language we're using. The difference with microservices is we tend to take that app, something that might be a big sort of monolithic thing, and break it up into lots of smaller processes, lots of smaller services, and they tend to be organized around something like business capabilities, and they tend to interact. This time now, we've kind of put the network in the middle, right? So a lot of times there's network communication. HTTP is a really super popular thing in microservices architectures, with the idea being that we've got these small autonomous units that can kind of be independently worked on and evolved and deployed. A lot of times there's automated deployment kind of involved in this sort of thing, and they sort of can evolve independent of one another instead of having to do these big monolithic releases that we were doing for many, many years. Does that make sense?
Yeah, it makes sense.
I would like to also to add something to complement Luke's point of view. I want to say also that when you switch to microservices, there is also a shift in a paradigm shift in the way you do programming, right? It's more like an event-oriented programming. The idea is now, before we used to do RPC, a style programming. So I have inside my big monolith, I have a service. This service is calling another service, and it's waiting for an answer. And because every services are living inside a single runtime, you don't see this interaction. It's intense. It's very fast, right? And now, because we are splitting all those services and we are just connecting them with a network. So basically, we have a distributed system here, right? And now the paradigm is changing. And instead of thinking about, okay, I make a request and I'm waiting for a response, the new idea is I'm sending an event, and this event should be processed by some services which are responsible for this event.
I think that's a really interesting point too. So, people will say, to me, well, I'm not using Cassandra or I'm not using DSE yet when I talk to, maybe when I'm talking to a new user or something like that. So, distributed systems, whatever, and to Dwi's point, a lot of people that are doing these microservices architectures, which is pretty much everybody these days, or a lot of people these days, you're actually, you're building a distributed system. Like, your database may not be a distributed system in and of itself yet, but a lot of people are building distributed systems and dealing with the challenges that come along with that.
Yeah, no, very true. Is that, would you agree then for, I'm going to throw out an opinion here and see what you think of this, but like, for me, my take on microservices, a lot of times that they're a black box, right? They have a contained set of functionality. Dewey High was kind of touching on this a little bit, and that each one of the services is essentially just going to provide whatever that particular service is. Is that something that you generally agree with?
I think, yeah. I mean, so I think part of the idea behind microservices is for them to be autonomous, for each one to be autonomous. And so, it's got whatever its sort of API is that it exposes to the world and the other parts of the system, the other services and whatever in the system. But how it actually works, if you're organizing them around business capabilities, it provides some certain business capability or some certain functionality in the site. And like how it accomplishes that, is to a degree a black box, it absolutely is.
We can even take the idea further. I mean, the implementation of the black box can be any programming language, because usually we assume that the same team is using the same programming language to build the whole system. It's no longer true. I mean, you have one service, you can use Node.js, you can use Python, Java, C#, whatever, as long as the contract is respected, right? And that's all.
Yep.
Yeah, it's a very good point. So we've kind of started to touch on this a little bit, but what do you guys think as far as like, why do we need microservices? Like, what kind of issues or class of issues do you think that they address?
Well, so I think we have touched on this a little bit already, but some of this idea of having a monolithic program that is so hard to build and maintain and keep track of, because whether or not you have a monolith, it could be well designed and it could be well partitioned internally so that there is some separation and isolation of different aspects of it. But we all know the temptations when you're working with a very large code base and it's in a single process, and you can easily go over and make that function call, access that other module. It's really hard to maintain that architectural discipline over time. So the microservices, in a way, is helping you enforce that discipline of, no, you have to cross a process boundary. You have to make a remote call, an RPC call, or you have to emit an event that's going to trigger some downstream processing. And that really helps to enforce the discipline. But that's not really the number one motivating factor why we do microservices. We don't do it just because we can't control ourselves, right? We do it for reasons of scale. Like, that's one of the major driving factors, is the ability to have, hopefully, these stateless services that we can, if I need more copies of my user service running than my video service, I can independently scale and provision as many copies as I need of any given stateful service. So that's just one aspect of the scalability that microservices help support.
So two points I want to make. So, first of all, to Jeff's first point about about the monoliths and how we may have them organized and stuff like that. I actually gave a talk at last year's Cassandra Summit where I kind of talked about how with our killer video reference app, we had a modular monolith. That's what I like to refer to those architectures as, is sort of the modular monolith architecture, where you've got sort of services in your code, and maybe you've got some really disciplined, engineers that are good, and they're not going to create that big ball of mud. But man, that temptation is there when you've got everything running in process. But to the point of the modular monolith, for anybody out there listening, and you haven't jumped on like the microservices bandwagon, the microservices hype train yet, a modular monolith is a totally legit architecture that can get you very, very far for a very long time. So like, I know the microservices are like the new and shiny thing and whatever, but be practical about it. A lot of times, especially, in early startups, you end up, kind of starting with a modular monolith of some kind and maybe evolving as time goes on to some of these other like a microservices architecture. And then the other point to make is around Jeff's point about scale. And so scale, not just in the technical sense. So one of the advantages of microservices architectures is that we can scale out, a service based on demand, or, that sort of thing. But also you hear a lot of people talk about being able to scale out people as well, right? So this goes back to like the mythical man month, and like if I throw 10 times 10 times the developers at it, they're going to finish it 10 times faster, which is never true, right? Whereas sometimes in these microservices architectures, it's easier to scale out individual teams that have responsibilities for various parts, various services in the system, and so it can be easier to scale and grow an organization and the people side of things as well. Something that we don't always talk about, I guess, as engineers.
No, that's a really good point. Actually, I mean, if you're listening to a podcast, you can't see me the whole time Luke is saying this. I'm shaking my head yes. And for all you project managers out there, let's take what he just said with the mythical man month. It's so true. So, all right. So we actually just started to touch on this. I know this next one is going to be like totally opinionated, right? So I'm very curious to see what you guys are going to say in this. But how would you go about designing a microservice? Is it going to be, say, based on functional unit tests or technical unit tests, or how do you identify microservices? Like, that's a big ball right there. I'm just throwing at you.
So I guess I'll jump in first. So I am like I've kind of touched on earlier in sort of my definition, I guess, of microservices. A lot of people tend to talk about organizing your services around business capabilities, and so it's what I like. Sometimes I like to think of an analogy, like an analogy of how did the business used to function before computers were involved, right? So like back in the day when there weren't computers, or maybe like there were very early computers with mainframes and stuff like that, there was probably a lot that was done with like pen and pencil, or there was some sort of workflow that the business had that that kind of made it work, right? And so I kind of like to go back to this analogy of how things maybe worked with pen and pencil. And so, things might go to a billing department, and then things might, and then there was another department that was responsible for pricing, and there was, a department that was responsible for the catalog, and, and so you try to think of it in terms of, what business capability is this, doing for, the product that I'm building, but then also there's some technical considerations as well. And a lot of times I like to think of those as to try and decide if something should be in, say, the same service boundary as something else is. Does it need to change together? Like, do I need to be able to sort of transactionally or in, maybe as near transactionally sort of make changes to these things? So are these two things related so closely that if one changes, the other needs to change at the exact same time? And a lot of times that can be sort of a technical indication that maybe this responsibility should be inside the same service boundary as another service.
Yeah. I totally agree with what Luke said. That I used to call them the hidden dependencies. When you try to split your monolith into microservices, you need to pay attention about the hidden dependencies, because when everything is living in the same runtime, you don't care, right? But then you start to say, okay, now this service, for example, user registration, right? When you want to register a user, you want to first save it to database, and then send him an invitation email, and so on, notification service. So think about also all the functional dependencies. Like, does it make sense to create a user without sending him an email, invitation email? Because from the business perspective, the user creation is only completely finished when the guy receives this email. Mm-hmm. So if you fail in the middle, functionally, there is something broken, see? So yeah, I tend to also reason about the functional unit. How can we make one functional unit to be as complete as possible?
Wow. Okay. So I'm gonna push back against some of this. So it's not that I don't agree with the idea that, if there's some kind of transactional behavior, that you wrap a service around it, but that doesn't work in all cases. There are some business transactions that are too big, that just span multiple areas, that you're not going to be able to put that within one service. So that's where some of the challenges, I think, arise. First of all, let's say that your data tier is implemented using Cassandra. It's not as if you can write a transaction that puts a new user entry into the user table, and then as part of the same transaction writes a record into another table that says that, adds to a log of customer emails that I've sent. And maybe that's a poor example, but you get the idea. Like we don't even have the capability in Cassandra anyway to do a transaction that spans multiple tables, especially not of two different data types. So at some point, we're going to have to not rely on our database anymore. If we're doing a highly scalable system and we need a highly scalable database that like Cassandra and what it supports, we're going to have to come up with some other mechanisms for achieving that transactional behavior across those boundaries. So I have some ideas about what to do there, but I'm going to pause and let you guys share your opinions on this.
So maybe I should have been clear. Like as far as transactions, it's probably a poor choice of words because transactions carry a lot of baggage, especially to anybody who's from database background.
Yeah, but that's the point. Business transaction doesn't necessarily mean database transaction.
Yeah, what I meant as far as the technical limitation of, the technical consideration on whether or not something should be inside of the same service boundary was more around consistency. So basically, the idea that when this changes, this has to change at the same time, kind of thing. And to your point about transactions and sort of we're going to have these business transactions which span sort of, you could never build, you'd end up having to build some Uber service that sort of did this. That's absolutely true. And so there's some other patterns of which I also have some thoughts and ideas on how you handle stuff that crosses service boundaries. And so basically my point was more towards like when data inside of, basically around consistency, like if things need sort of immediate consistency, a lot of time, which I would tell people most of the time you don't, right? So like we're so trained because we're so used to building things on relational databases and being able to like kind of reach into different tables and, wrap it all in a transaction and have it all change together. We're so used to this idea that we need consistency. People always talk about banks, like, man, I'd hate it if they didn't use transactions for banks, when they take my money out and stuff like that, when that's actually one of the most like eventually consistent sort of systems that's been around forever.
It's very true.
It's banks, right? So a lot of times you think you need consistency, and I would tell you, well, first of all, if you do think that you need that, you probably should like check your assumptions and start thinking, well, again, go back to that mental model of pencil and paper. Like how did that work before? Like, did somebody have to walk a change order down the hall to the billing department or something and hand them a piece of paper, and they, and then there was some period of time where some other process had to happen? Like, I mean, we've been dealing with eventual consistency in our in our business processes forever. And so I don't know I think it's just relational databases maybe trained us to think that we need everything to change together. So.
Yeah, no, and I thought maybe you had a comment there, or am I just now calling you out?
Yeah, so in fact, it's amazing that you introduced the idea. So if we listen back, you say the words consistency, okay, transaction, a very loaded word, changing together. So in my mind, it resonates as distributed systems, right? Ideas in a distributed system. How do you ensure that you have consistency, atomicity also? Because, when all your services are running in the same runtime and this runtime is shut down for whatever reason, well, everything is down, right? Dead or alive. Now, if you split them across different services, which are linked by a network, you can have some services up, the other service is down. So the most common answer to this kind of, okay, how can I ensure that everything is up? So the common answer is to scale out horizontally. It's mean that now a solution to high availability is, okay, instead of having one single instance of your service, you have multiple instances. So even in the case of failure of one service, you still have other service to take the business on. Okay, so now we are talking about high availability, horizontal scaling. So what I want to say is, in fact, when you start doing microservices, you are de facto designing a distributed system, right? And when you design distributed system, you should be aware of all those notions, right? As Luc said earlier, we need to challenge our way of thinking. Now we need to adapt to this eventual consistency world.
Yeah, so let's take an example of that. So I want to go back to that example that that Luc brought up earlier of kind of adding a new user to the system, and we're going to add a new user and create that record in the database, and then we're going to make sure that we send them a welcome email to our platform or whatever action it is that we're trying to take. So I'm going to propose a design here, and then you could tell me if you think it's acceptable or what the flaws are or not. But we don't necessarily have to try to tie in a very strong way the storage of the new user in the database in a single kind of transaction, I know loaded term, with sending that recognition email. One of the things that we can do is take advantage of some asynchronous processing. So I would argue that as long as I can ensure that that new user has been written to the database and that I fire off an event that can be captured in some kind of event queue or streaming data store, as long as I have that record, then I can have another process that is going and picking up those messages and sending the user confirmation emails. Agree, disagree? Is that a good decoupling of concerns?
Totally agree, but you are missing an important point is because now you are reasoning about event-based architecture. I'm sending an event. Some services will capture this event to send out the email or whatever. Now say that in a distributed world, failure exists, right? It does exist, so you have to cope with it. So let's say you lost this event or you lost this message somehow. You need to be able to replay this, right? Okay, in case of this sending out this message to the email service fail, I need to be able to replay this event multiple times. And now we are coming back to the idea of idempotency, right?
I asked for exactly once. I want exactly once delivery, Juihai.
So that's the challenge now. Now you need to have some, because it doesn't make sense to a phone user to receive twice or three times the same invitation messages, especially when he clicks on a link, it no longer works, right? So now we are talking about how can I design my system so that the triggering of the email message is executed only once, even if I know that I may have to resend the same event again and again. So that are all the challenges of exactly once delivery semantics and so on. And there exists some system to cope with that, of course.
Yeah, I love it. And I'm a big fan of event-driven systems. So I'm like, put some pub sub messaging at the edges of your services for service collaboration. I'm a big fan. A lot of times though, you do, depending on, sort of depending on your message infrastructure, right? So like, the example you gave, a user signs up and some event gets published somewhere to maybe a streaming queue or something like that. Depending on what you're using, if you're using something with persistent messaging, right, where you get at least some guarantee of a time window where, that message is going to be persistent to the message infrastructure, that can be helpful. If you have sort of more ephemeral messaging infrastructure, so like, it gets published and what happens, like I just said, what happens if, that other service that's supposed to send emails is down, and misses the message kind of thing. Then I found that a lot of times if you're dealing with sort of these more ephemeral, kind of messaging infrastructures that you have to have some sort of service, or you have to have something built into the service to go back and look for the stuff that you missed, basically. So a lot of times you have these batch sort of in the background cleanup processes. This is something that I'm dealing with actually right now in a DataStax Academy project I'm working on, where we kind of have to have this background process that goes back and looks for things that we might have missed. So that's another really super common feature I've found in architectures like this.
Compensating processes, right?
Yeah. And a good pattern, if anyone's listening and wants to go look into patterns for dealing with this sort of, I need multiple services involved in this business transaction thing, there's a pattern out there called the Saga pattern that is like awesome for dealing with this kind of cross service sort of orchestration, and you can do retries and all kinds of cool stuff. So definitely check that out.
Okay, so we've talked about like some of your general opinions on microservices and design implementations, things like that, ideas there. So what do you think the takeaway for developers and folks listening to the show is regarding this conversation?
Well, microservices are hard, first of all. So, we didn't even touch upon
There's your takeaway. It's hard.
we could probably do multiple shows on this because we didn't even talk about specific technologies and how to share data between services, and we didn't really talk about event-driven architecture. I mean, there's so many things we could talk about, but like once you put the network in the middle, you get all kinds of failures that you didn't get before. And
network in the middle.
Yeah. Well, I mean, you get some advantages. We kind of talked about some of the advantages, but also as far as it impacts the data tier, just to talk specifically about, maybe for a second about how it impacts the data tier. One thing that people really struggle with when they start with something like Cassandra or DSE is, like the whole idea of like having to denormalize your data. And when you get to a microservices architecture, like it actually can help with some of these problems that people have when they build on DSE and Cassandra. So you have a smaller surface area a lot of times of operations that can possibly impact your kind of denormalized data. The other advantage is one thing that's really hard with DSE and Cassandra is it's really hard to tune clusters. And if you're doing sort of the microservices way of maybe having, say, independent clusters backing some of your larger microservices, it's going to be a lot easier for you to tune for one specific workload as opposed to trying to tune for your one cluster that services 25 microservices, each of which has completely different characteristics, about how read heavy it is or write heavy it is or whatever. So you actually this architectural pattern in your software can actually help some of these problems that people kind of have, or pain points they have when they work with DSE and Cassandra.
Yeah, and I just want to mention that I really love how you put that with having a smaller surface area, right, when you're dealing with the microservices. And essentially the way I took that, right, is less to think about as far as your data tier for each one of the services. It really helps simplify the problem.
That's exactly what I mean. Yeah. There's less to think about.
Oh man, I think we should definitely do another episode on this topic, because we need to talk about what David did in Killer Video, how he got a graph to access the data that was owned by multiple different services, which could be viewed as a violation of that separation of concern. So we have a whole conversation to have about that.
Yeah, there's a whole conversation about services that are sort of reporting type services that need data from lots of places. That's an interesting problem, and it would be interesting to get some people's takes on how they're solving, that problem.
Yeah, it sounds like another show, Jeff. We got to set it up.
Okay, let's do it.
And then we can go into how I violated all of the patterns. All right, so you guys, as far as like takeaway for developers or anything, Dweehai or Jeff, you guys have anything else you want to follow up with, or?
Yeah, I have my final word for this is, microservices is cool, but it is not for every project, right? You shouldn't use it as a golden hammer. So some project is well suited for microservices, some are not, because they are so small that it doesn't make sense to split them into different services. So don't abuse, judge wisely. That's my final word.
Is it wrong that when you said Golden Hammer, I immediately thought of Super Mario Brothers, and now I can't remember if that's the right game? It's Donkey Kong. I think I just totally messed that up. Anyway, that was the visual that I got. Jeff, you got anything to wrap up with here?
No.
All right, totally putting you on the spot. We're going to end with nothing. No. So everybody, thanks again for listening to another Distributed Data Show, and we'll sign off. Thank you and goodbye.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.